to that. Okay, how about now?
Yeah.
All right, sorry. Um, so a lot of people are talking about how we can do reasoning with LLMs. We probably can't, but we'll come back to that in a second. There's this question about what the relationship is between reasoning and language more generally. And the reason that this tends to come up and the reason that it gets so much hype and so much whatever else is because there's also a certain notion that we think in language. So if I was to posit these as our initial questions for this discussion today, then we can go ahead and just answer them really quickly. So where does meaning come from? No idea. What is reasoning? Nobody knows. Do we think in language? Sometimes. So, how many people here have an inner monologue? So when you're thinking things through, you're okay, cool. So the first thing is lots of hands, but not all hands. That's because some of you are like, I don't raise hands for participation in talks. Thank you very much. Have you been to a computer science conference? We're introverts. But the other possibility is that there's actually a lot of people who don't think in language. There's a lot of people who think more spatially, and then there's a process by which they try to transform that into language to convey it. And so this is kind of a lesson in like being careful about things that we find intuitive in a sort of Moravec's paradox kind of way for robotics. Things that we think are easy are not necessarily the right paradigm for actually thinking about stuff like language. So we think, oh, well, I'm using language in my internal monologue. When I read a book, I hear all the words, stuff like this. That must mean that this is sort of a fundamental basis for thought. We're going to argue a little bit on that point, but I'll come back to it in a second. It's just useful for us to first acknowledge that bias that some of us are going to inherit. So where does meaning come from? So one way that we might go about this is we might think, oh, well, it's because we interact with the world. So we interact with the world. This is what gives us meaning. We are able to ground it to our perception. That's the most familiar. Increasingly popular, though, is the sort of self-supervised, particularly for like, if we have video access, we have all of YouTube, like, can we download all of that and then try to get meaning out of that? That does have precedent, right? So it is not the case that you learn simply by doing. You also learn by observing. Now, how much of observing requires that you have mirror neurons, which allow you to simulate the actions of the other person? We can argue that. But you do learn by observing. You do for both meaning more generally, for actions and stuff like this, and even for just linguistic structures. So it turns out you actually start learning language in utero. So you actually start learning the phonetics of the language that is in the outside environment while you are still in the womb. And so you're actually just, you have clearly no ability to ground anything, but you're starting to figure out some basic patterns and some basic structure. So it is useful to be able to sort of just imitate observations, but I think all of us would agree it's probably not sufficient. And then the final thing that I want to sort of put a little bit of into your minds as part of this talk is the notion of sort of social intelligence. So there's a whole argument about where sort of agency comes from. And one of the basic arguments tends to be that fundamentally it has to do with being social creatures. And so the fact that we have social structures gives us situations where there are trade-offs to be made. And so therefore we have agency because we have these sort of a spectrum of options and we're weighing the consequences of all of those before we take them. The problem with social intelligence is that it is not manifest in the world, right? It's manifest inside of the heads of everyone else that we're talking to. And so then we end up with theory of mind. We can go into that a little bit more, but basically we end up in this situation where we're having to try to figure out what is the internal world model of the person that we're talking to. All right, so far I have philosophized and told you nothing. So let's try to kind of move from here a little bit. The first thing you might think is if I'm going to try to connect language to the world, I'm going to do instruction following. So there's a lot of people who've done instruction following. I like to always throw to Peter Anderson as I think one of the moments for a lot of us in vision language navigation, where he collected scans of, we used the Matterport scans for inside of rich people's houses and then connected them to language descriptions in order to give some sort of connection between those. But we can also reference things like all of Joyce Chai's work before that, Stephanie Telex, and so forth. I've also done some stuff in this space. So this is some work that we did in a simulator called Thor, where it was connecting abstract goals like put a gray bowl at a location, and you had articulated objects, and so there was a little bit more richness. And the reason that I like to juxtapose these is because it forces us to ask a question, which is what information or meaning do we get access to from a static environment that we're moving through versus what information is only accessible to us once we're actually interacting with the world and it's changing. And then obviously we can move to the real world. And so this is some work from like a year ago on trying to connect simpler language, like placing an object in a receptacle, but actually executing on our OBOT. Ignoring the task specification for a moment, going back to that same question, what is meaning? So to what extent does the fact that there is noise in the environment matter? The fact that the control stack is not deterministic the way it would be in simulation, does that matter? Does that imbue meaning? Is that important to the notion of concepts, or is that distinct? Great, not going to answer it. So instead, I'm going to ask this question, which is, what do we want for meaning representations? So if we were to sort of come up with our own vision of what an ideal meaning representation might look like, it might include some of these sorts of properties with this kind of caveat with regards to language. So we might want a set of basis vectors for meaning that sort of make sure that important distinctions are separated on different axes. We might want it to be something that allows us to capture a bunch of knowledge. Knowledge is a pretty broad, underspecified term here, so cultural context, nuance, things like this. We might want this representation to be reasonably sparse because we want to be able to make sure that we're, it's a sort of a low rank situation. And the problem is that if I go to use language as my representation for this, then I end up with this problem, which is that words are meaningless. So I have this tension, which I'm going to go into for the next couple slides for a second, which is basically, in some sense, everything that we want in a meaning representation is language. On the other hand, if I was to give you a word in a language you do not speak, it would be meaningless to you. So it would be a nonce word of some kind. And so I have this issue where it's like, here's this thing that seems like it might be really good, and we're seeing a lot of evidence for it. Why are LMs so good? On the other hand, it doesn't really make sense for LMs to be good. So if I ask you, why are language models so good? The answers that we typically get are things like this. So we say, oh, well, scale. You have so much more data. So it's just data. It's like all data is good data. As long as I have data, I'm going to get some good representation. It's a little bit unsatisfying. Another possibility is words are sort of easy. Vision and action are hard, So maybe the issue here is that it's, there's something just sort of simpler in terms of the inherent structure with words that makes them simpler to model versus the physics of the world. Or I'm sure all of you just think that God loves language and that, you wrote the 10 Commandments in language, and clearly that's just the way that we should do this. Okay, these are some terrible hypotheses. The thing I want you to take away is actually that how many people have ever seen this figure before? This is the sort of a pretty version of the phylogenetic history of language. We'll go into this a little bit more, but basically, the key thing about language is that it didn't just show up. It went through a multi-thousand-year evolutionary process that got to what we have today. You only use a word if the word is useful. You don't keep around words that you don't need as a culture, as a society. And then what has happened is that as society has shifted, those priorities have shifted. And so we have introduced new words. We have words like Skype, even though they screwed up and now we use Zoom. And we have, words that are defunct that have just basically, in the garbage bin of history. And so this happens not just at the individual lexical level, this happens at an entire linguistic level, where you have basically a set of languages that are that sort of branched out and became the basis for new ones. And it's easiest for most people to see this in the kind of Indo-European family of languages, sort of seeing the relationships between Italian and Spanish and Latin, the way that English, because the Anglo-Saxons were conquered by the Franks, have sort of a mixture of Old French and Old Germanic. You can sort of trace all those kinds of lineages. I'll give you one that may be a little simpler for you to look at. I realize this projector is a little bit small. Apologies. This is just the alphabet, so let's not even worry about words. We're just going to look at letters for a second. So what you have here is, oops, I can't even read it myself on there. I can't read it on here either, so that's not going to work. Proto-Sinaic, I think is what it's saying. But the one that most people are familiar with is Phoenician. So Phoenician, Archaic Greek, Archaic Latin, the Roman alphabet, and the modern script. And so we have this transformation. It's not exactly a one-to-one. There's some shifting from some more symbolic forms to these more abstract forms. Okay, so the reason that language is good is not because there's something special about any of the tokens. It's not because there's any meaning that is explicitly or directly encoded in any of the tokens. Obviously, a single letter change typo can completely change the meaning of the word. So it's not any of that. It's the fact that they're basically social basis vectors. They're basically just that we as society have decided over the last few thousand years that these are the concepts that we think are most relevant, and these are the relationships between all those concepts. That's cool. Doesn't solve our problem. So now we have this issue. I have my nice basis vectors over here, and I have the world over here. And what I need to do is figure out how to take my meaning and embed it into these known bases. And that is what we're mostly seeing right now. So what is GPT-4V or O, or I don't know, I'm sure there's something better I'm supposed to be referencing. What are they doing? They're basically doing something called text bind. So they're basically taking the world in some way, and then they're trying to take an embedding of, let's say, the image or whatever it might be, and project it into the basis vectors that they got from learning the language model. Now, that is not a bad idea. As we said, those basis vectors exist for a reason. Those basis vectors, though, are also going to be deficient because by definition, they're abstract. I'm going to assume that the majority of people in this room speak more than one language. Is that safe? Okay. If you speak more than one language, I assume you've had the following experience, which is that somebody says, please translate this for me. And then you do this awkward thing where you go, well, like I can translate the words, but it's like not really going to get the meaning. Okay. So that moment is basically this issue, right? Which is that you can translate the bases, but that's not sufficient because you sort of need the interpreter. You need the encoder and the decoder, which in this case is you or the agent, that sort of imbues all of those with meaning. So we have a really great representation. It allows us to do things like common sense reasoning because of some notion of similarity, except at the same time, we don't have something that allows us to properly encode or decode out of that space. And so we can then ask these questions about like how we should do this loop. How should we be taking meaning and turning it into something that's maybe useful to leverage the fact that we have this good representation? And then there's the flip side, which is how do we use those bases to actually sort of guide our actions? Now, you've seen this very successful in certain places. So where have you seen this really successfully? There's this incredible runaway literature of agents. So there's this whole agentic AI thing that's happening where like every CEO, for some reason, thinks this is how they're going to finally automate away all of their employees, where they're going to just have language models take actions in the web or in a video game or something like this. And in the vast majority of cases, the reason that it works so well is because there is no gap. There is no separation between the world and the bases. They're the same thing. So you just have a bunch of tokens, and those are the semantics, right? So submit is submit, and that's the end of it. So if we want to move to a more realistic setting, so I'm going to show you some stuff. I'm not going to, don't overfit to any of my work, but like, I'm just going to show you some stuff to give you a sense for how I think about some of these things. So if we move to a real world, then we're going to have something that's closer to this, right? So this is some work by some students of mine, where if we have built up our sort of standard SLAM map of the environment, that is not a good representation for moving into those bases. So there's a question about like how to bridge that gap. Of something that might be more useful would be some sort of a structured representation of the semantics of the space, right? So, these regions are coherent in some way. And so we would then want to learn some kind of correspondence between these. And the point of this work is that what we show is that you can basically do this with captioning models and then with language models as summarizers. So here's the basic concept behind this, and I'll tie it right back, which is that as I move around some space, there are a bunch of important motion primitive style details that I'm going to ignore for the moment. But there's a second sort of functional or social structure to the space. So this room, for example, could be many things, right? We could set up a robo soccer league in here, and then all of a sudden we would have a new region of space which has the playing field and the goals and stuff like this. There would be a bunch of things that would get codified in that process. Instead, we oriented the chairs in a certain way, and so therefore we've created a canonical conference room, things like this. So the space itself doesn't dictate anything. It's instead that when you sort of observe the organization, the usage, that dictates what the space is. And so what we can do is we can ask the language model, like, what are the things that you see? So like, I see a hallway with elevators and signs, or I see open sunshine or whatever else. We can do this as a bunch of these individual nodes. And then we can take that and we can try to do a summarization process where we build up hierarchies to more abstract things. So like this is a multifunctional space. Pretty generic answer, but that's probably true of the room that we're in. And so then a person could show up in such a space like this and could ask things like, find me the stairs. This would be a direct grounding of meaning. So this would be that the meaning of the word stair is literally the location, the waypoint in the space, or the image, that realization of it. They could ask, where can I buy drinks? In which case, you would basically, well, in this particular room, you wouldn't, well, there's actually kind of a liquor cabinet there somehow. So understanding that there's some sort of structure, implicit use there. And then can you like describe the functional aspects of this building? And then once you have those kinds of things, you could pass this to an agent who could then use your map in order to navigate to a specific waypoint. And so here's an example of something where you have a kind of, I think, clean distinction in some sense between the world and then the sort of functional bases of language. So once I have shifted from here to here, I'm in abstract reasoning space. And here I'm going to therefore be able to leverage language models sort of appropriately to take actions, because that's the kind of stuff that there's knowledge for. I don't really care about this. It's not the point of this talk. But this is sort of, a little bit more sort of structurally how it's done in terms of encoding those graphs, handing it to a language model and so forth. And then I'm just going to let this play really quickly and say, like, then what you can do is obviously you can actually execute it. So maybe it'll play. Nope, or not. All right, well, pretend that a robot has just heard this instruction and has moved to the exact right place it's supposed to go. Okay. So the first part of this talk is basically just to try to get you to think about language a little bit differently. And then from the perspective of sort of like why we're here in this particular workshop is to then think about like, well, that means that if this space exists, maybe the way that I should view this space is a little bit differently. So I should think about it in terms of if there's smoothness in that space, if there's redundancy in that space, then those are sort of implicit structures that should be guiding some aspect of this space. So that means that you have a source of supervision, which is that basically people have already decided that these concepts are related in some way. And so therefore we need to figure out how to leverage that. But we can't do it naively because we have this execution problem. So our big grand challenge is the following. How much time do I actually have? Because I feel like lunch starts in like 2 minutes. Okay. All right. We're going to go really fast. All right. So I want to show you one. So I want to introduce one second concept really quickly. Which is related to this, which is that so when you go about trying to do these things, one of your temptations is probably going to be that you want to use the language model as a planner because you're like, oh, well, the language model has this information. That's just going to guide this for me. So this is some work where we're trying to kind of characterize what that actually means, because you almost never actually mean that the language model is going to do everything. Yes, there's some work we can get into with robot foundation models where you're trying to predict delta actions and stuff like this, but in general, you're not doing that. In general, what's going to happen is you're basically using a task and motion planning style framework where you're going to assume that your language model is going to choose some tool, some motion planner or something like this, and then it's going to execute that. And so if that's the case, then you have some context by which you choose what you're going to pass to your tool, to your planner. You then have the actual tool itself, and then you have the output, and this all goes inside of your LM. So there's a bunch of sources of error, pieces that can fail, and then pieces that could be recovered. So for example, your object detector, your action planner could be failure points. So what we do is we sort of analyze this. I'm going to skip a little bit ahead. We analyze this in terms of a faulty calculator. So the thing that I want you to take from this is if the language model is actually a planner, and if it actually has an understanding of all these things, then it should be the case that if I permute the output of a tool, it should detect those errors. So if I take, for example, a simple calculator and I change one of the digits or I change the magnitude, then if I said, hey, what's 10 times 50? And I gave you back a number that didn't end in a 0, you would know that I was screwing with you. Even if that's an easy one, but still you would, even if you couldn't do it in your head, hopefully you can do 10 times 50. So here we have language models. Here's GPT-4, here's Gemini 1.5. And then here's what happens when you mess with the tool in terms of how much worse their performance is. They basically just overtrust the tool. If the calculator said, oh yeah, here's the answer, even if the language model knew the answer when you didn't give it a tool, it will take the tool's response over its own. Now, the reason that this is important is because this is the beginning of where I want to introduce the second concept of metacognition. So the reason that you are able to address a tool failing is similar to the reason that you're able to think about thinking, is you're able to look at situations that you don't actually have enough information to be able to answer, but still are able to assess whether or not the things that you're seeing are sort of in distribution. So there's kind of a distinction between the explicit knowledge that you actually have and your ability to do distribution matching. So that distinction is something that I think is worth studying. Not right now because you need to eat. So we're going to do this, different than the one that I actually sample from or use for making decisions. That then begs a second question, which is, can I use a single model to both evaluate and act, or do those need to be separated? If I have multiple models, do they need to be similarly large? Do I need to have both of these types of language models? Again, I don't have the answer to any of these things. I think a concept that might be interesting is to think about whether or not we have sort of internal critics in like a classic sense of it, right? So maybe what's happening is that we're all running actor critic in our head or something like this. And the critic is giving us some sense for whether or not we're actually calibrated on this. But this begs this question, which is like, what's the relationship between what we know and what we can learn? I am completely out of time at this point. So what I'm going to do is tell you that it is not the case that you should just trust language models to do this naively. Here is a quick result from some other work that you're not at ACL right now. So you're not here and presented. But basically, if you have language models sort of engage in a social interaction or dialogue, and then you have something like GPT-4 tell you whether or not they felt that secrets were kept or privacy preserved or whatever else, then what you're seeing here is the distinction between the score that how preserving in red GPT-4 thinks versus humans. And so this means that like law breaking, here's humans being like, these are all very morally questionable situations. And here's GPT-4 being like, everything's totally cool. Don't worry about it. And so that means that if you then try to do something like use self-reinforce or some other kind of thing like this, in order to try to use this notion of I'm looking at myself in order to improve myself with models that are already faulty, you end up seeing this gap continue to widen where humans are things are getting better, but people are concerned. And GPT-4 is like, no, we're A-okay. Everything's great here. Okay, so closing takeaways. Language models are annoying. I grant you this, but language is cool. And so some challenges that I sort of want to just leave with here are, when are these basis vectors useful versus restrictive? How much knowledge do you need to reason about the unknown? How do we think about this issue? And then how do we formalize these into actual objective functions so that we can then try to use that in order to improve our own systems? Done.
I think that was a great talk. We will take some questions.
I'm also happy to just like chill. If people want to go to lunch and like a couple of people come up and chat, that's also totally fine. I get it.
But if anyone wants to ask some questions, raise your hand, we'll take your mic.
Yeah, go for it.
So, I guess the first thing you were saying is that the language provides you some structure.
Yeah.
We should use it to guide search. Like, imagine we ran a thought experiment where we pull out the different worlds, and it doesn't have the same type of language. It has some different type of communication. Like, do you think there's something fundamental between like structure that comes from bandwidth limited communication and that guiding search, or do you think that it's just the nature of the world that we're in right now?
Okay, so I think there's a couple pieces to that, if I understood it correctly. So first, in case people interpret your question as asking whether or not the Sapir-Whorf hypothesis holds, it does not. So it is not the case that language structures the world or your perception of the world. So it is the other way around. We can get into that, but that's established. So then I think the really interesting part of your question is the bandwidth limited part. And I think that is exactly correct. And so one thing that people sometimes think is that they go to different languages and okay, how many people here speak Chinese? Okay, Chinese, when you write it, is an incredibly dense written form, right? Because every character is going to give you, a ton of information, and there's also going to be poetry in the choice of characters. Does anybody happen to speak Turkish? Great. Okay, so Turkish, on the other hand, is going to have this agglutinative morphology where you can make words that are arbitrarily long by adding suffixes and suffixes on it. And so people look at these things and they think, well, in Turkish, my word is 50 characters long, and in Chinese, it's 1 character and it gives me everything. So clearly, this is more information dense than the other. When you actually look at the spoken version of both languages, equivalent. So there's like some small differences here because some languages encode gender, some code whatever, stuff like this. But basically, it turns out that regardless of the language, we are sort of information bottlenecked in the same sort of way. And then there's a question of like, what is creating those pressures? And the main reason is that in general, with the exception of this situation, you're not willing to listen to someone monologue for 30 minutes. And so like you have to have the social pressure leads to the creation of terms that are abbreviations, are shortenings in order to get to the point where just the critical piece of information is going on. So if there's some way for us to replicate that, for example, with our, okay, let's like an autoencoder of action in the world or something like this, then you could imagine that the result of that should have some of those same sorts of properties, except it may not have the sort of cultural relevance because it's maybe not conditioning on enough variables. Yeah.
One other question? What's this for lunch?
Totally cool. Thanks, everybody.
Thank you, Ned. And yeah, we'll be back at 1 p.m. We're